All right, making predictions with experimental probability. Let's look at this lesson. Example 1, this person found that the experimental probability of her making a bullseye when throwing darts is 2 out of 10, or 20%. Out of 75 throws, how many we predict they're going to make? Okay. So we're looking for the part over the total. Let's start with the probability. So 2 out of 10 times this person is going to hit a bullseye. But we're not throwing it 10 times, she's throwing it 75. So how many out of 75? So here's your proportion. Now what you do is cross multiply and solve. Ten times x. We'll just go straight down. 10x equals 75 times 2. 150. No, it's an equation, so we have to solve it. 10 times x, divide by 10 on both sides, and x equals 150 divided by 10. We have a 0 on top, 0 on bottom. Those can just cancel, so we're left with 15. If we didn't get a whole number, we'd have to round, because how many bullseyes can we predict? You can't hit half a bullseye. It either counts or it doesn't. That's what we get down here, 15. Let's look at number 1. At the bottom here, car rental company sells accident insurance to 24% of the customers. Out of the total number of customers, how many customers are predicted to purchase insurance? So 24%. Every percent is out of 100. But there are not 100 customers, there are 550 customers. And we want to know how many out of those are going to purchase the insurance. So, cross multiply and divide. $100 times x is 100x. 24 times 550. I'm going to go to the side and multiply that out. Four times 0 is 4. 4 times 5 is 20. 4 times 5 is 20. Plus 2 is 22. Bring down to 0. 2 times 0 is 0. 2 times 5 is 10. Carry the 1. 2 times 5 is 10 plus 1 is 11. Add straight down, 0, 0, 2, 2, 1, 1. Oops, this is what happens when you don't line it up. Should have gotten 0, 0, 2, 2 and 1 is 3, and 1. So let me rewrite this. 100x equals 13,200. Now we get x by itself by dividing 100 on both sides. Nice thing here is we do have two zeros, so these will just cancel each other out. And we're left with 132. So, Car rental company sells accident insurance to 24% of its customers. How many do we expect? We expect 132. Moving on. Doctor's office. We're looking at example 2. Doctor's office records data, concludes that on average 11% of patients reschedule their appointments. The office manager predicts 23 appointments will be rescheduled out of a total of 240. Is her prediction reasonable? Okay. So, is it reasonable? Well, let's start. What's the probability here? 11%. Every percent is out of 100. So, how many are going to be out of the total, which is 240? Now, we didn't use this 23. This 23 we're going to save until the end because that's the prediction. That is the prediction. So we're going to compare our answer to this and see if hers is reasonable. So, we have our proportion. Now we cross multiply. 100x equals 240 times 11. Go to the side and do that. 1 times 0 is 0. 1 times 4 is 4. And 1 times 2 is 2. 1 times 0 is 0, 1 times 4 is 4, and 1 times 2 is 2. Now add them up. 0, 4, 6, and 2. 2,640. Here's our cross multiplication. Now we need to solve and get x by itself. So divide by 100 on both sides. Fortunately, one of these zeros cancels. When you solve this, you get 26.4. This is our answer. Now, this doesn't necessarily make sense because we're talking about appointments. And we're going to say, just for this sake, you can't have 4/10 of an appointment. It's either a full appointment or it's not. So we'd have to round this, but we're actually comparing. We're just saying, hey, are these two numbers reasonable? Is 23 close to 26.4? We would have to round this probably to 26. Is it reasonable? It's close enough. The prediction is a little low, but not low enough to where we would say it is unreasonable. All right, number 3 at the bottom of the page. In emails to monthly readers, 3% of emails come back undelivered. Editor predicts that if he sends out that many emails, he'll receive this many notices for undelivered email. Do we agree with the prediction? All right, so we need to compare our answer with that 437. So 3%, every percent is out of 100. And the total that he sends out, how many out of 12,372? So we're solving this, then we're going to compare it. Cross multiply. 12,372. So yeah, multiply these out. 3 times 2 is 6. 3 times 7 is 21. 9, 10, 11. 3 times 2 is 6, plus 1 is 7, and 3 times 1 is 3. All right, so we have 37,116. We cross multiplied. Now we need to divide. So divide by 100 on both sides. X equals 371.16. We'd have to round this because we're talking about emails, and you can't have a part of an email. You either have the email or you don't. So we're going to say X is right around 371. So we're actually comparing this to his prediction, and even though we're talking about 12,000 emails, we're going to say that this is not really, well, we don't really agree. His prediction is pretty high. So we're going to say, let's see, do you agree with his prediction? No, because we got 371, so his is too high to be reasonable. The prediction is too high to be reasonable. Moving on to example 3. Example 3. And online poll. For movie site, shows polling results for a new movie. If a newspaper surveys 150 people, how many people can it predict will like the movie based on the poll? Is the movie site's claim accurate if the newspaper has 104 people say they like the movie? So that's our prediction. We're going to say if that's accurate. We're going to see if this is accurate. So how many like the movie? So do you like the movie? 72% said yes. So 72 out of 100 say yes. So how many out of 150? We've been multiplying these out all lessons, so let's just use the calculator. 150 times 72. Let's cross multiply here first. 100x equals 150 times 72 is 10,800. Now we will divide by 100. And x equals 108. And it's good that we got a whole number because we're talking about people, so we could not have gotten a decimal. So, how many people can we predict will like the movie? About 108. The movie sites claim that 104 people say they like the movie. Is this accurate? Yeah, it's accurate. 108 out of 100 people. So we would say that it is accurate because it's pretty close. 104, 108, only off by 4 people. Last one of the lesson, number 4. On average, 24% of customers who say they buy shoes in this store typically buy 2 or more. So 24% by 2 or more. One weekend, this many customers purchased shoes. How many can be predicted to buy 2 or more? And then we're comparing it to this. So 24%. Every percent is out of 100. So how many out of 350? 24 over 100 equals how many out of 350? Cross multiply. So 100x equals 24 times 350. $8,400. Once we cross multiply, now we need to divide by 100. And we get 84 people. Has to be a whole number. We'd have had to round if it was not a whole number. So, one weekend, this many customers purchase shoes. So we anticipate out of 350 that 84 will buy 2 or more. This problem is saying that 107 customers bought 2 or more. Did more customers than normal buy 2 or more? Yes. Because we expected 84, but the actual number of people who bought 2 or more pairs was 107.